Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is aluminium extraction. Aluminium is extracted with the help of an ore called as the bauxite ore. So first of all, we know the ore of aluminium, which is the bauxite ore, and this bauxite ore is largely aluminium oxide. Okay, but it also contains some impurities, and the impurities are abbreviated as the SIT impurities. So when I say the SIT impurities, I'm referring to three things. These are the oxides of, so I can say impurities are oxides of, and oxides of what? S stands for silicon. So oxides of silicon, oxides of iron, and oxides of titanium. Okay, so the ore contains impurities of oxides of silicon, iron, and titanium. So this ore definitely cannot be used directly. So we need to purify the ore. So the next thing that happens to this is purification. So the ore is purified. Okay, and how do we purify the ore? We purify it by adding sodium hydroxide to it. So first of all, the ore is crushed. So we crush the ore. So ore is crushed, and what are we doing to it? We are adding sodium hydroxide to it. Okay, so by crushing the ore and adding sodium hydroxide, so then what happens? Two things happen. First is the aluminium oxide, it dissolves in sodium hydroxide. Okay, and we get a compound called as sodium aluminate, NaAlO2, plus we get water. Okay, and what does not dissolve are the impurities. So what remains undissolved are the impurities. So we are able to use filtration and remove these impurities. So these are removed by filtration, right? Okay, now let's balance this equation to the left. Now this sodium aluminate that is formed is processed further. And what does it form after further processing? It forms pure aluminium oxide. Okay, so now we are very happy we got pure aluminium oxide. Yes, definitely we are happy, but the problem is this pure aluminium oxide has a very high melting point. That's around 2000 degrees Celsius. It's somewhere between 2040 to 2070 degrees Celsius. Now it's very difficult to maintain this high temperature. It is not economically viable. So we need to reduce the melting point. So now our job is to reduce the melting point of aluminium oxide. So how do we do that? We do that by adding cryolite. So we add cryolite. Okay, and what happens when we add cryolite? There are two things that are going to happen when we add cryolite, and cryolite is Na3Al F6. So the two things that are going to happen are, first is the melting point obviously will reduce to 1000 degrees Celsius, and secondly the electrical conductivity of the electrolyte also will improve. Okay, so that means it saves on our energy cost as well. Okay, so therefore we are adding cryolite to it, and then we can conduct the electrolysis. Now let us go to the actual electrolysis. So now the electrolysis can begin. Okay, so I'll explain to you how this electrolysis begins. So then we will study about the electrolysis of Al2O3. So now this Al2O3 contains what all things? It contains cryolite along with pure aluminium oxide. Okay, I begin by drawing the electrolytic cell, and I'll explain the parts of the cell as well. As you can see, this is the electrolytic cell. The cathode and the anode are both made up of carbon, and the dipping electrodes are the anodes, they are the positive electrodes, and the lining of the electrolytic cell is again of the carbon. So you have graphite or carbon being used as the anode and the cathode. But remember, anode and the cathode are made up of the same material. Electrolyte is molten cryolite and bauxite, okay, which is now aluminium oxide, you can say. So ideally you can say the electrolyte is aluminium oxide and cryolite, okay. So the temperature has come down to 1000 degree Celsius. Well, what happens at the anode and cathode? At the anode, which is a positive electrode, what will happen, and at the cathode what's going to happen? Now before that, let me tell you, we are electrolyzing molten ionic compound, that is the molten aluminium oxide. Now there are only two kinds of ions that are present in it, one positive ion and one negative ion. So obviously the overall reaction is easy to gauge. What is the overall reaction, if you can just think of it? So well, the overall reaction is the breakdown of aluminium oxide into aluminium and oxygen. So obviously you can expect that aluminium will be attracted, the aluminium ions will be attracted to the negative electrode, which is the cathode. So you will have the reaction for aluminium at the cathode. So Al 3 plus 3E minus gives you Al. This is the reaction at the cathode. And what happens at the anode? Who's attracted? At the anode, obviously the oxide ions are attracted. So the overall reaction is 2O2 minus 4E minus gives you O2 gas. Now remember, at the anode, oxygen is, the electrons are being lost. Therefore, at anode what happens is oxidation. This is exactly what you would expect to happen at the anode. And at the cathode, electrons are being gained and reduction is gain. So what happens at the cathode is the reduction. Okay, so you have the overall equation. This is the overall reaction, and here on the top these are the reactions for the anode and the cathode. Also, it's very important to see that the oxygen is forming at the anodes. Okay, so oxygen is coming like this up. Okay, oxygen is traveling upwards, and while traveling upwards, what happens? It comes in contact with the hot carbon anodes. Okay, so therefore what it is going to the carbon anodes is going to burn them away, and consequently we need to replace the anodes after some time. So ideally there are two gases coming out of the anode. One is the oxygen gas, which is the result of the electrolysis of aluminium oxide, and second is the carbon dioxide gas, which is being formed due to the reaction between the hot carbon anodes and the oxygen gas. So ideally this is all in the extraction of aluminium, and it's advisable to make your notes, watch the video, pause the video, and do as I'm explaining, so that way it will become better for you to remember the concept. Okay, it's very important to understand that aluminium is a very reactive metal, and which is why it must be extracted by electrolysis. But when exposed to air, it coats itself with a layer of impermeable aluminium oxide, and this layer of aluminium oxide prevents the layers of aluminium beneath from corrosion. So it's very useful to use aluminium when you have to use it for a purpose where corrosion is a possibility. Okay, uses of aluminium, you can say it can be used as a cooking utensil because it is a good conductor of electricity. Also, because of its low density, it can be used to make aircraft bodies. So the uses can always be related to the properties. Well, that's all in aluminium extraction in today's video. I hope you like watching my video. Please do subscribe to my channel if you like. Thank you.